Well, hello, good morning, and thank you for joining me here in my shop on October 19th for what may be the last day in my shop for this radio. And just a couple days ago, I was thinking, boy, I'm never going to get this radio working properly, and here it is, working fairly properly, except one strange thing, and that's this weird tuning effect, which I believe I'm going to solve in a matter of minutes here. This weird tuning effect where it seemed as if you tune one way, like if you turn the knob one way, all the stations are, let's say, here. But if you tune the knob the other direction, the stations all appear to be shifted on the dial. So you go this way, there you go this way. That's the strangest thing. In the last video, right towards the end, I mentioned the idea of hysteresis. Not that I think there's a hysteretic action in here, but it's like that. And while I was eating my sandwich at lunch yesterday after finishing in the shop, an idea suddenly just sprung to mind, and I ran in here, and sure enough, I think I spotted the problem. I hadn't done anything to the radio. I spotted the problem and thought, well, that'll be great for tomorrow, which is now. So we're going to take a close look at what I believe is the problem. And guess who's responsible for the problem? It would be me. It would be me, unfortunately. Okay, if you make a problem and you can fix a problem, then that's okay. Let's just take a look at this capacitor here. This is the capacitor that I just gnarled these outer plates. And in trying to get them back into place, well, I got them substantially back. They're certainly not in their normal way if you look at them. But have a look down here. Now if I can get the camera in there. See something funny going on? When I was having my lunch, let me just tell you what went through my head. You've looked right at the problem. Hysteresis from tuning. And so I started thinking, well, what if the capacitor plate out there is dragging against the frame of the capacitor? What if it's dragging? So if you tune one way, you drag the plate this way. If you tune the other way, well, the plate would dig in a little bit, wouldn't it? And it would cause it to change its shape a little bit, bend a little bit or something. Wouldn't that be hysteresis? That's what went through my head while I was chewing on my sandwich. Well, maybe this is what's happening. I ran in here, I just showed it to you. Let's take another look at it. If you didn't spot it, I'm going to point right to it. And then we're going to experiment a little bit with it, or make some observations about it. So, pretty much dead center of the screen. Let's see if I can get in with a pointer. This plate, this one right here, is bumping into a nubbin that is sticking out on this wheel. That's what I think is happening. Now whether it's doing that hysteretic action or not, well, I guess it would be. I am now going to tune the radio, and we're going to watch this thing. Oh, I wasn't expecting that. Look at. Doesn't look like it's touching the plate. It just looks like it's getting closer. Now I'm at the end of the run, which is why that gear is shifting that way. That's not a normal tuning place. Can I go? No, I think I can go all the way around with it. So this would be more normal tuning. So I don't really see anything happening. They're moving in unison. I thought one was dragging over the other. Well, I think it's just a matter of reaching down there, bending that plate away from that post, and the effect will disappear. As simple as that. Well, you might say, oh my God, the plate is shorted to the post. Won't that ruin anything? No, these rotating plates, they are grounded. The insulated plates are the stator plates, the ones down there. believe it or not, it's easier to insulate the fixed plates, and it's easier to ground these plates. It's grounded by that, well, I don't know if I can really see it. Somewhere there'll be fingers or springed fingers or some kind of spring action that'll force a ground. Maybe we're looking right at it there. Maybe it's, I don't know. I don't see anything obvious in this, but somehow there'll be something that keeps the rotor grounded even though it's rotating, right? It's rotating on some points. Okay, so I'm going to bend that plate. How come I didn't see this first time around? If I remember right, I had all kinds of headaches doing this kind of thing. I'm trying to do it as controlled as I can. Springy little devils. Let me turn this capacitor up all the way. That is all the way. What's happening? Where did the little nubbin go? What have I done here? What? There was something there a minute ago, wasn't there? You can see an interesting little mark on the plate down there. What? What happened? Was it a little piece of dirt or something in there? What's happened here? Like, I guess whatever it was, I knocked out of there. Okay, that's not at all what I expected. But you know, hey, that's never happened before. You notice that in life, everything goes the way you expect it. Nothing odd ever happens in life. Okay, well, we got to try the radio and see if the effect is gone. Just looking to see if I can spot some debris fall out of it, but no, it's going to have fallen into the radio, and maybe it's gone somewhere else to cause some other haunting effect. Okay, we're going to play this radio in a moment, just see if that resolved it. Okay, radio's warming up. Let's just see what happens here. Make sure the volume's down. Switched on FM. Got the FM antenna in there. Hopefully we're going to get something. Totally normal. Even though it's a bad reception, that's okay. That doesn't matter. The tuning is normal again. So that's what it was. It's the plate up in contact with the gear. And I can't exactly explain why it had that weird hysteretic effect, but it did. And it's gone. Excellent. Okay. couple more things. One of the things I've noticed in the radio is the pointer, when you tune it and the top of the pointer is being pulled, the bottom is dragging, and this makes the pointer do this across the front of the radio. Now it'll scratch up something. Well, there's nothing there to scratch up actually. So in most of these radios, there's a wire that controls the position of the pointer down at the bottom there. Let's see. Let me just see it with this camera. Pretty tricky to see. And there definitely is a couple wires down there. Couple. And I'm going to guess the pointer's on the wrong side of one of them. That's what it looks like. Very hard to see. It must be impossible to see in the camera. Well, you know, it looks like one wire is pulling the bottom of the pointer forward, and then the other one, actually it's up kind of halfway up, and then the other one is here, keeping it from coming too far forward. That's what it looks like. Is it actually dragging? Why exactly is it making that motion? Okay, let me put the close-up. What was that? Well, sometimes this radio tends to suddenly sort of pick up its sensitivity. Got quieter. Well, I have to take it out of my shop to find out how well it's working again. Okay, back to the problem with the pointer though. A couple more things that obviously need to be checked on the radio. I don't know about this. You know what? I noticed earlier that the antenna lead wire, which is copper, I'm sure, is attached to these aluminum pieces with just screws and just under pressure. Looks like it's just a pressure fit. Is that going to survive all this time? Aluminum develops a non-conductive adherent corrosion coating on it. That's what you're seeing all the time with aluminum. Corroded aluminum anyway, that's gone dull. That's probably what's happened up here. I think so. Freshen that up somehow. I noticed there was glue on part of it too. Okay, we'll deal with that next. First, we want to take a look at this situation with the, I don't know if my camera's focused properly for doing this. Let's just see. So, no, it's focused. We can't see the bottom of the pointer there. Okay, let me just drop this here if I can. Change the focus on it. Bear with me here a moment. Just opening up the dialog box for the camera. zoom down, focus down near the bottom. The pointer. Okay. Get a little better look at it here. Now when I tune the radio, put my hand in here. See the pointer at the bottom doesn't move. Till you move it far enough. Still not in focus here. Okay, a little more. There. I'm trying to figure out, is it dragging on the front panel? Now this, you may think, oh, that's just a minor problem. Why would you worry about that? Well, when you look at a radio and you look at the pointer, bearing in mind this pointer is only visible through little slots. But on other radios, you can see most of the pointer, and if it does stuff like this, it's really distracting. It really, you know, a simple thing like this really uglies up the radio. So I think it's rubbing. It's hard to explain. I think I see where it's rubbing. So now how's this arranged again? So there's two guide wires down there. One on either side of the pointer. The pointer is traveling in a swathe of guide wires. If you look up near the top of the image on the screen, you can see the guide wires appear to be converging, as if they're spread. One looks straight and the one on the left looks like it's pushed out. Also see the back of the glass and how dusty it is. We're going to deal with that in a little bit. I think it needs to be in front of that guide wire. The lower one. Okay, in front of the guide wire. With any luck now, I can just kind of grab this, kind of just twist it up and set it correctly. There's enough play and everything for me to do that. Stick my fingers in here. You can just lift it right up. What happened? So this, now's our chance. This is definitely part of the picture. But how come it went so quiet suddenly? This is definitely part of the picture though. I don't know. Okay. You have to admit, I don't know an awful lot when I'm in here. Get a hook. Boing. It just went boing. As soon as I dragged it up over the, dragged it up this way. As soon as I dragged it up, boing. Actually, that was the pointer that jumped. So that's fixed. That's fixed. Yeah, pointer's working. That's good. Okay, got that solved. Now, let's do this antenna thing next. I'm going to turn the radio off while I do this because I've got some high voltage parts sticking out here like this thing and over here, and I'm not paying close attention. So, better that it's off. And what did I say I was just going to do? Yeah, that's usually an indication that coffee is needed. Totally, I just lost my mind there. Okay, that's okay. I'll find my mind somewhere. Okay, let's take a close look at how they've done the antenna connection here. You get a good look at it through that camera to really see what's up. You see the incoming, it's actually the outgoing. This wire's heading to the radio, and this is the small lead that heads over here. The wires are twisted together to a resistor and then down into the, of all things, the speaker wiring. Perhaps finding a ground there? I don't think so. I think this is the poor man's AM antenna for this radio, I think. Okay, so looking at these now. So an observation I made last time was that the screw on the right hand side there has some kind of glue or something on it, near it. The other one doesn't. You know, I'm going to take a wild guess. The aluminum is glued in place, and when they tightened down this screw, some excess glue came out and ended up looking like that. And that would suggest this was done with this whole thing upside down, so it would flow out like that instead of flowing down onto the components. That's my guess. So it's just glue that's holding the aluminum, and that's why it's only on one side, just because they had some excess there. Okay. Now, if you know anything about corrosion, you've heard about mixed metals, and look what we've got here. We've got aluminum sheet. We've got a washer made of unknown material. We've got a connector, like a two-way connector, this part here, the soldering's done to. And then we've got what looks like a brass screw. So aluminum is very high on the electromotive force scale, if you like. The electrons are anxious to leave. I think we could put it that way. There's a certain differential electronic pressure in aluminum from other metals, and this is what sets up the whole corrosion, mixed metal corrosion problem. The thing about that is you need either, this has to be submerged in conductive water. Tap water would do it, but you'd have to have this submerged for that kind of corrosion. Now, aluminum quickly forms an aluminum oxide layer. If you scratch aluminum, you'll see it's shiny underneath. It has that metallic sheen. I believe that sheen, what you're really looking at is light photons being, I don't want to say bounced back, re-emitted by the electron cloud. I mean, that's probably not a correct description, but that's how I like to think of it. So if you scratch away at the aluminum, you begin to see the sheen better. That's not Martin sheen, that's electrons. And that's why sheeny metal or shiny metal is going to be a good contact surface. But over the long run, oxygen's going to get in under that washer. The washer is going to be lifted by the corrosion products that are building up. Even though we're talking atoms of thickness here, we're not talking about voluminous stuff. See, the difference between steel corrosion and aluminum corrosion, many metals are unlike steel and more like aluminum. When steel corrodes, the volume of the resulting product, iron, some kind of iron ore, iron oxide or iron whatever, is far greater than the iron it actually came from. And so as the corrosion proceeds, the corrosion disrupts itself. It disrupts its own product, if you like, and turns into what we're all familiar with, this big pile of rust that you can scrape off, and then usually you see there's some metal missing underneath because it's turned into rust. Other metals don't do it quite like that. When they corrode, the resulting corrosion product remains tightly adherent to the metal and is of roughly the same volume. And so it doesn't flake off, it doesn't disrupt itself, it's not self-disrupting. And it can form a very adherent, very thin layer of corrosion product. And it stops the corrosion because it prevents the metal underneath from contacting the environment, even though you can't see it. So stainless steel is like that. If you look at stainless steel, you see the nice sheen and all that. What you don't realize is there is a corrosion coating, if you like, on the surface. So that's what's going on here with the aluminum. There might even be some kind of plastic or something on top of here too. Or is it just dirt? Oh yeah, it's just dust I'm kicking around. Okay, so looking at the system here and trying to figure out what to do about it. That's simple. There's only so many things you can do here. Simple thing would be just to release these screws and tighten them down again. Release the screws, pull the stuff apart, see what's happening underneath. Try to clean the aluminum. Now when you make an aluminum, listen, if you've got aluminum wiring in your home, you should be periodically checking the connections in your outlets. And for your own life, make sure you put in aluminum outlets and switches if you change them. Oh my God, don't put in a copper one. House fires can come from connections working loose. And in the case of copper and that, even though the copper is corroded, that we're looking at. When we look at copper and we see it's not shiny, it's brown. I don't know if I haven't got any here. That's really, it gets a brown layer on it. Oh, I'm not showing it to the right camera. That brown layer is conductive, so that's why you can just take a piece of copper wire. You don't have to clean it necessarily. You stick it underneath the connector, and you're golden, and you're golden for good. Not so with aluminum. Aluminum also can flow a little bit. So you put it under a screw under a lot of pressure at first. After a little while, the aluminum conductor will flow a bit and loosen up. So you got aluminum wiring, get out your screwdriver and check all your connections. Especially if you have a cyclic load. What would a cyclic load be? Heavy cyclic load, your freezer, your fridge. You plugged into an aluminum wired house, you better periodically check that outlet. That's my advice for what it's worth. Or you're going to get this kind of effect, that's what I'm guessing. Only it's going to lead to a fire. Well, I think obviously the solution here, I've talked enough. You simply take these off and see what happens. Underneath, is there any kind of surprise here? I doubt it. So, because you can't solder to aluminum, so they put this piece in here to give it some place to solder to. So it's copper or something like that. Does it look corroded? Yeah, it does. Whoop! This thing looks corroded. Well, it's obvious it's steel because it's magnetic. It's plated steel. What they plate it with, because that doesn't look like steel unless it's some kind of special steel. It's probably plated, but typically you plate steel with zinc. That's not a good actor in electrical environments. Same sort of deal as aluminum. What do we see about the surface here? Oh, it looks pretty shiny. And you can see the screw itself is biting into the aluminum here. If there's any connection problem, it's this washer. This washer. Pretty clean on one side. Well, only solution I can think of is to clean these things up, abrade them a little bit, a little bit of, I wouldn't want to use regular sandpaper, but something that'll abrade the surface a little bit, and then put it all back together. And I think it'll be fine after that for another 10 or 20 years. I thought for a while that this glue stuff here was some kind of sealant, and they just hadn't got the sealant. They missed one side. It didn't do a good job on this side. That doesn't make sense, does it? The glue story is a much better story. A big screwdriver and a small screw. Let's see what this one washer's got glue on it. Ooh, it's really in there. It's not exactly the best tool. Okay, Swedish fish knife. Finish fish knife. Swedish fish knife. Does the trick. Tore the aluminum a little bit. Tore it right off. Tore a piece of aluminum off. Once again, aluminum looks pretty clean underneath, doesn't it? So, there's different alloys and stuff. Maybe, there's a particular alloy here that doesn't build up a lot of corrosion. But when you look in the longer shot, you can see that you don't see much of a reflection in this at all. Whereas in the parts here that are cleared away, you can see a better reflection. This isn't a very flat surface here, but so this has corroded a bit. If you're making aluminum connections, there's usually a compound that comes with it, and you're supposed to clean the aluminum way up. Does anybody use aluminum wiring anymore? Aluminum wiring was a big thing here in Ontario, and I'm sure Quebec too, for a period of time in the late 60s and through the 70s. It was advertised on TV, aluminum wiring, way to go. And the reason for that is Canada's got a lot of aluminum. Quebec has a lot of aluminum ore, bauxite I think it's called. And Quebec has the magic elixir. A lot of low-cost electricity, all created by solar energy. Well, okay, I call it solar energy. Everybody else calls it hydro. Falling water, going over falls, or you get the static head of water, and you can generate electricity from it. What I would point out is, how did the water get up here in the first place? The sun put it up there. It's a form of solar energy. When the water's collecting in the lake up high on the mountain that you're going to draw from, that's solar energy being used to fill that lake or reservoir or whatever it is that you're drawing on to get your head of water. Well, in Quebec they have so much of this. They built this huge dam quite a few years ago, a big, long dam, and they have the potential. I'm pretty sure Quebec is completely powered by hydroelectricity. Maybe I'm wrong about that. But I think the capacity of their source is twice what they're using now. And they make a lot of aluminum in Quebec already. Aluminum requires vast amounts of electricity to win the metal from the ore, using electrolysis, reverse electrolysis, whatever it is. Okay, lots of talk for not much work here. I will attend to this and put it back together, and I don't think we'll ever have a problem again. Okay, got that back together, not a big deal. Now let's just consider what is going on here. So, the length of this wire, all this stuff is very critical to make the antenna perform at its peak. And we can guess the engineers who designed this did that this thing is peaked. So you got to wonder, though, when you attach another piece of wire here and carry it on and then short the ends together, how can you possibly do that? Doesn't that just short all this out and just kind of ruin the whole deal? And the answer is no, because this wire is a very particular length here, and this has an effect on the FM frequencies that it does not have on the AM, much lower AM frequencies. So from an AM point of view, regular broadcast radio, this might look like just nothing special here at all, just some wire. But on FM frequency, 100 megahertz, this thing may look like an open circuit. Even though it's shorted here, it may look like an open circuit. And so it won't affect any of this. And that's probably what they've set up here. And why are they doing this? Well, they're trying to provide some kind of antenna for the AM radio so it's not naked, especially in the store when they're trying to sell it. And if they can actually tell the potential buyer that this radio doesn't need an outdoor antenna. It may work well just the way it is, and there's a good chance it would on a local AM station. Then you're more likely to sell your radio because it doesn't have the hassle of needing an outdoor antenna to work. But there's something more to show you about this. I have to just get the chassis back in here. Okay, what we want to take a look at now is a switch which might not be recognized as a switch on the back of this radio. It's right here in the antenna connecting area. It's this thing. Now, this can be in any one of this position, where it is now, this position, or over here. What is this switch? And you see that they've got this cut out for even more switches that are not installed on this model. So if we just take a look at the back, I'm kind of winging this. The switch the switch right here, the post that it rotates on, is right here. It goes to a terminal tucked between the two FM terminals. The two FM antenna terminals here. There's another terminal here. And a wire going down to this coil. There's a coil here and a coil there, and the other side of the coil goes to the FM connections. So what are they doing here? So this switch is connected through these coils to the FM side of things. Now the sliding part of the switch, this part down here, is the 1, 2, 3, 4 terminals for it. Well, 2 of them are the FM antenna, so not going to be those. The other one is here. This is hard to see, I'm sure, in the camera. There's one right here, and the other one is over here, and it looks like there's a capacitor right in here. Oh, there's a capacitor right here too. FM antenna goes in right here, and the AM goes in here, and one is ground and one is not. Let's take a look at what it says on here. It's important to figure this out. You're going to operate this radio. Antenna, air day. That's got to be ground. So antenna is on here. So we look at the back again. So the AM, and if you had an external AM antenna, it would be plugged in here. You see that there's a wire going from here up to this terminal. Where am I going with this? Maybe we need to look at the schematic to really sort this out, because I don't think I can see all that I need to see about how they've done this. Let's take a look at the schematic. It's important to get this switch figured out. Is this in the right position? It's got, looks like 4 and 5. Looks like 1, 2, 3, 4, and 5. These ones are not numbered because you would never swing it out here. It's just either 4 or 5. Okay, we're looking at the schematic and we're looking at the antenna again. Here's the FM antenna. These might represent those screws I was fooling around with. This could be the coils we were looking at just now in behind that switch. This would be the center piece. This would be the switch. Right here has a lever that is currently set on 4. So currently the connection is made this way. 4, and we run it over here, reaches this is an antenna symbol. So if you had more wire hooked up to the antenna terminal for AM, it would be hooked up here. So you see, if you don't do that, if you have no antenna, then the antenna is going to be this, up to here. It's not much of an AM antenna, but it's better than nothing, because nothing on a radio like this means nothing. It means nothing's coming out of the speaker. Now what if you flip this over to 5? If you flip it over to 5, you place a ground right here. Well, that's interesting. We can guess that these coils are big enough that the FM signal at 100 megahertz or so is just not affected. They look like open circuits to it. They can't get a signal through them. The coils are too powerful. Why bother with the ground? I can only guess it's to eliminate any signal that might be present. If you leave this, if you just left, like if you just open circuit this wire, so the little wire, maybe the switch would be here, you have this piece of wire, or just open circuit it here. You'd have this piece of wire in the radio, maybe picking up something that's undesirable. So that's probably why 5 puts it on the ground, gets it out of the picture. So this radio is set to operate with the internal antenna. If you hook up the external AM antenna, we're just going to put it right here. It's just going to add in. If you hook up an external AM antenna, if you can pick up an FM signal, and I'll bet you what happens is the FM signal cannot get through these coils. So any FM signaling on the AM antenna wire can't make it into here. Something like that. So they figured out a tricky way to, kill 2 birds with 1 antenna, basically. That's what it amounts to. So it's on position 4. It's probably the correct position to leave it on. We could flip it over to 5 and see what happens. Don't know that it would make any difference at all on FM. FM is what we're really concerned about with this radio, because that's what the owner's bound to listen to. Unless he's a sports fanatic, and he's going to want to listen to sports on the AM side of things. So that's the story there. So we need to do one more thing, mostly to make me feel comfortable with letting this radio go back to its owner, and that's to check the grid blocking capacitor on the output tube. Someone's at my door. My wife's in the process of booking our 5th shot for anti-COVID shot, and she just needed my health card. Okay, that's what's happening here. Fifth shot. Whew. So I checked the cathode resistor and the bias voltage being developed across the cathode resistor. I found it to be around 15 volts, if I remember right, which I thought was a little high. Why don't we check that just for interest's sake? It's all related to what I'm concerned about. If the bias on the grid of this tube is not correct, and if it's less negative than it should be, then the tube's current conduction goes up. You wouldn't notice anything in the speaker, you wouldn't notice anything anywhere, but meanwhile the tube is running hotter and harder than it needs to and wears out sooner. This is already wearing out faster than these other tubes just because of the way output tubes are pushed. So that's a 6AQ5, was it? 6AQ5, 6AQ, I think. It's an EL84, wasn't it? No, hold on. EL84 is a 6AQ5, I think. 6AQ5. And they don't refer to the it's a North American book, so they're not gonna. Well, assuming this is the right one, which I think it is. I'll check in a bit. I want to look at the bias voltage and typical operation. Class A amplifier. Typical operation, same as for type 6V6, within the limitations of the maximum rating. So that's not what I want to find. Class A amplifier characteristics: grid number 1 voltage minus 12.5. Well, this was pretty close. Okay, that's definitely in the range. That's definitely in the range. I thought maybe it should be much lower, but not the case. It has to be high enough to allow the input signal to range up and down. Maybe I should, I don't know. Sometimes my graphing, system isn't all that great. So another problem now that can happen with this grid, and it's a silent killer, is the capacitor that's job is to block DC from accidentally reaching the grid may be leaking. And if it's leaking a little bit, and it just takes a little bit of a charge, it can push the grid potential positive. So you still have the cathode resistor creating the bias, but the bias is being kind of overcome by an additional positive charge building up on the grid. That's not good, and it's silent. You don't know what's happening. Perhaps if it's really bad, you'll hear distorted sound. So we're going to want to go after the capacitor on the grid of this tube. To do that, we have to once again visit the schematic here. Okay, now we go down to the other end of the radio, the business end here. So here's the grid, and here's this, which I don't, what is this? I still don't know what this is, but I'm not going to worry about it. Come up here. Here is the grid blocking capacitor. Now, 25 nanofarads. So 25 nanofarads is a 0.025. It's 2 dots and a crown. Two dots and a crown. Oh. Condenser. Mit. Is that width? Kenshin das Offenbleichens. Yeah. No idea what that is. If you're German, you're jumping up and down now. Jim, you know what that means? What does that mean? What is with these little tails? Condensator. Maybe I should take a moment and try to get this translated. Okay, got to correct something here. I was looking at a 6AQ5. It's a 6BQ5 tube. That's the output tube. And we come down and do the same thing. Typical operation. Grid number 1. Control grid voltage. -7. I read -15. So what that suggests to me, and I don't know if I'm right or not, is there's too much current flowing through that tube, causing a larger voltage drop on the cathode resistor than expected. Now, why would there be a larger current? Because the grid is being pushed positive by a leaky grid blocking capacitor. So we're talking about everything in this area here. This is the tube socket right here. Of course, the radio's not on. I'm sticking my finger in it. A couple other interesting observations right in this area is this resistor, which appears to have overheated at some point. We looked at that earlier. There's a capacitor here that's barfing its guts out right at the end, which I think I saw much earlier on and then kind of lost track of it. Well, there it is. The barfing out its guts thing is an indication that it's hot. Why is it hot? Well, it's sitting attached to the socket of the hottest tube in the radio. So the heat could just be coming from there. It doesn't really mean the capacitor itself generated the heat, but with its guts sticking out there, it's not the best deal. It probably needs to be replaced, but that's not the capacitor in question. The capacitor that I am interested in, I haven't found it yet. It's got to be around here somewhere. Okay, so I'm going to continue hunting here. Hunting along. Okay, that thing's sorted out a little bit. This leaking, or not leaking, but physically leaking capacitor here is on the plate circuit, and it just goes to ground. And I believe its main idea is to drain out any RF that's still making it all the way just before it goes into the speaker output transformer. So I think that's what this guy's about. He's taking a beating because he's got 300 volts across it or whatever, and plus it's being cooked. So that poor guy, he's got to go. If this guy's not working, not really sure what happened with the radio. Maybe might get an oscillation in it or something. I don't know. The capacitor that's doing the blocking job. So it's on this terminal here. This is a 50K resistor coming off over here. And you can just trace to this guy. And so this is the blocking capacitor, and it's of the sort that you can't really rely on, I think. This guy's also taking a beating. He's got not nearly the beating the other one's taken. This has got like 60, 70 volts on it, something like that. And if it leaks, it's going to put a charge on the grid. So we're going to, now, while I'm doing this, and this is what happens with these radios. While you're poking around on one thing, you find something you would never expect or even look for. And right now I'm looking for my camera. Where'd my little camera go? Because I want to show it. Oh, here it's right in front of my face, for crying out loud. That's usually where things are. So I'm going to put the close-up camera in here. I'm going to take a look at something weird that I found. Maybe it's not weird. Maybe it is. Seems weird on the face of it here. Let's get it right in. I think that'll do it. I'm looking right into this area here. Well, obvious where I'm looking. Let's see what we got. Now I may have to focus things a little bit here. Give me a second. And we'll just focus in a little better. Okay. I want to look a little more this way. Now what I'm going to do is I'm going to rock. I don't know, I'm going to change the camera setting here. I'm just going to back up a little bit if I can. Do I got the spot I want? No. 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 Okay, I don't, I try to avoid putting these on video, but sometimes I'm in a little bit of a rush on things. Why am I rushing? Because it's almost 12:30, for crying out loud. It's time for lunch. Just get in here somewhere about like that. And a little focusing I think might help here. So what I noticed while I was poking around is if I touch this black capacitor, a whole pile of stuff moves. Including, this is the weird thing, this piece here. Let me get a pointer. Oh my gosh, for some reason I've got a chicken skewer. Okay, never mind what I'm using for a tool here. Let's just say this would normally be found inside a turkey. Look, what's that? What's that metal bar there? Like, what's going on here? The metal bar I'm talking about is this piece here. What? Why is this here? And it's loose. Like I don't design radios to have parts that do that. How could this even happen? I mean, what could be going on when they were making this radio that they ended up with this metal bar sticking out? Is it supposed to go somewhere? It looks like I think I got the answer. Oh, I think I got the answer. So if you look at this one here, whoops, this one. How can I point at it? Here, this one's fixed in place, and just over here, I'm working in the camera backwards. I'm having trouble. There's a hole here, and notice the discoloration in the board. So I think this is popped off, but you wouldn't expect it to leap right out. And really, how is it even held in there, in that hole? How is this one held in? The other one, this one here. I don't have this plugged in, do I? No. How does that get... No, there's another hole over here, so... Well, it's quite a mystery. Now, I think I'm going to leave it. Read like this right now. This is the end of today. Tomorrow I'm going to pick right up on this area here. We're probably going to end up changing out this capacitor and finding out if it's any good or not. And we'll certainly change out this one here. See all the dust that's collected on it? That's an indication that high voltage is... that this thing is doing high voltage duty. 250 volts, that's all. 500 picofarads. You wouldn't think that's a picofarad capacitor there. Okay. And we'll poke around and see whatever else is in here that we can spot. Let's just take a look at this. So this resistor, which is, I'm pretty sure this is indicating it got hotter than intended. It shouldn't look like that. Could have been a sudden thing. But who knows what the history is on this radio? I don't know. But we tested it. It's good. It's wire wound, so it can take a beating. Yeah, I think I'm just going to leave it here for today, and tomorrow we'll pick up with the capacitor issue around the output tube. And maybe that'll make tomorrow the last day for this radio. Oh, I shouldn't put it that way, should it? It should be the first day for this radio. So thanks a lot for watching, and we're almost done.